Okay, it's time for us to get started. Hello, everyone. Welcome to What's New in Hyper-V. I'm Ben Armstrong, Program Manager, working on Hyper-V for a very long time now. People ask me how long I've been working on virtualization for, and these days I say practically an eternity. But today I'm here to talk about everything that's coming in the next release of Windows Server, and specifically everything that's there that you can actually go and play with in the current technical preview that's out. But before I get going, I always like to ask questions so I can understand a bit about the audience that I'm talking to. So a couple of easy ones to start with. How many people here have private cloud deployments that they work with? Fantastic. How many people are using public cloud in some way, shape, or form? This is great. Let me highlight, when I was out here 5 years ago, if I'd asked that question, the answer not only would have been no, it would have been no, and you would have been throwing stuff at me. So happy to see people coming on board with figuring out how to use that technology. So on the private cloud, how many people are using Hyper-V? Fantastic. How many people are using VMware? It's okay, I won't get mad at you. Seriously, we have to stop that, though. I will just say I'm not going to spend a lot of time talking about VMware. These days, whenever I do talk to people using VMware, the number one reason why I hear that people are using it is because they're comfortable with it. And it's been a long time since someone's actually come to me with a really good technical issue for not using Hyper-V. If you have a reason why you feel that you can't move off VMware to Hyper-V, come and talk to me. Find me, please. I would love to have that conversation. So back to the Hyper-V side of things. How many people are using Hyper-V 2012 R2? Good. How many people are using 2012 still somewhere? Okay, a couple of hands. How many people 2008 R2? Okay, I'm glad to see not many hands there. 2008 R2, 2012 people. We need to get you to 2012 R2. And I'll talk about that a bit in this session. So thanks for the raise of hands. It's good. Always good to know. I actually did a session 2 weeks ago at a non-Microsoft event. And when I asked how many people were using Hyper-V, there were 2 hands in the room. So I had to be like, right, we're going to change the way we talk about this. So anyway, as I said at the beginning, the goal of this session is I'm going to be talking about everything that you can do with the current technical preview builds. I actually had a lot of people, as I was submitting the session and as we've been coming up to the show, say, hey, Ben, why are you doing a level 200 session? You're usually the guy who comes out and does the 300, 400 session. And the answer is, there's so much stuff in the build, I can't speak about it all at a level 300, 400 kind of level. If I did, we would be here all day. So if there's anything that I touch on, and I'm going to be talking about like, hey, here's the feature, here's how we built it, here's why we did it, moving along to the next one. If there's something where you're like, hey, I want to know more about that, feel free to track me down. We also actually did a great, it ended up being 8-hour Microsoft Virtual Academy session with me and Mac McSpirit, where we essentially did this presentation in 8 hours. Going through and digging in deep on all of that, and it's up online, and you can dig in and you can go and look at the specific things that you're interested in. So with that, let's get started. One thing, I am going to be talking a lot about Windows Server, but a lot of these features are also available in Windows 10. Another quick show of hands, how many people here are Windows 10 insiders? Yeah, good stuff. We love the Windows 10 Insider program. We actually have a lot of features now where we're actually putting them out through the Windows 10 Insider program first, and then following up and releasing them in the next Windows Server build. So it's a great way to keep on top of the technology and play with it before a lot of other people get their hands on it. So now, shifting gears, talking about what I'm actually supposed to be talking about. So whenever we start on a release of Windows, we sit down and we go through an activity where we do the planning and we figure out, hey, what are we building? Where are we going to be focusing? And hopefully it should come as a surprise to no one here that for the Hyper-V team, our primary focus is making cloud great. Now, when we say cloud on the Hyper-V team, we mean both public and private cloud. Because one of the great things about Hyper-V is the bits that you get running on Windows Server are exactly the same as what we run in Azure. They're exactly the same as what you run on Windows 10 desktop. It's something that we've worked really hard to maintain, is it's a single product, single set of binaries. So when we're building this, there are often times when we will build a set of features or functionality first for Azure or for public cloud, and then we'll make it available for private cloud. Sometimes it goes in the other direction. For us, it's all cloud computing. So we sat down and we looked at this, and we came up with a number of areas where we wanted to focus on. And I'm going to be going through these areas and talking about the features in each area that we have built to enable this. So the first area was enabling cloud-borne applications. And the idea here is a lot of what we've been doing with cloud computing to date has been about how do we take your existing infrastructure, your existing applications, and bring them across to a cloud environment. And we're now at a stage of industry maturity where we're starting to look and go like, okay, let's take a step back, and what does it look like if instead we started building the system for cloud environments first? And there are two big investments in Server 2016. The first one is all the work going on around NanoServer. So another show of hands time, how many people here know about NanoServer? Okay, I would like that to be all the hands. Now for the awkward one, how many people have tried NanoServer? Yeah, that is not enough hands. So NanoServer is actually available in both the Technical Preview 2 and the Technical Preview 3. And this is going to be odd as the Hyper-V guy. The number one ask I would have of everyone here is if you do nothing else after coming to this session, go home and play with NanoServer. Honestly, it takes you about 30 minutes to get it up and running in a VM on Hyper-V, not much longer to get it running on hardware to host a Hyper-V workload. Start playing with it. We really think that this is key to our strategy moving forward. So what is NanoServer? NanoServer is a new way for us to build Windows. It's a new way for us to build and distribute Windows Server. It's about going from a world where you install installation of Windows Server that is capable of doing everything you could possibly want, and then having a mode where you go like, okay, I'm going to enable this, and a couple of days later I'm going to enable that. And instead going to a world where you start out with a clear vision. I want this to be a web server. I want this to be a Hyper-V server. I know exactly what role I want for this. And then you can build an installation of Windows that has only the bits needed for that workload. So when Windows Server 2016 comes out, we are going to be making strong statements about Hyper-V on NanoServer being our best practice deployment. Why are we going to do that? A couple of reasons. The first one is just to highlight the resource usage of Hyper-V on NanoServer is amazing. We're talking 450 meg hard disk. We're talking under 200 meg of memory, just freeing up the resource so you can use it to run virtual machines. The bigger thing, though, is what it means for operations. From an operational point of view, one of the things that we've been tracking as we've been working on NanoServer is what we expect the impact to be on patching of environments. And so what we've been doing is, as we've been building and working on Windows Server 2016, we've been tracking the patches and updates that have gone out for Windows Server 2012 R2, and we've done the analysis on how the different installations of Hyper-V on Windows Server would be affected. So over the last 12 months, if you had Hyper-V on a full installation of Windows with the graphical shell, with Internet Explorer, with all the bells and whistles, you would have had to have rebooted that system 11 months out of 12. 11 months out of 12, there would have been an update that required you to reboot. If you're running the same system on Windows Server Core, while there's a significant reduction in the number of patches, you only need one update that requires a reboot in order to have to reboot the system. So while we can actually look and say, hey, if you're running Server Core, you've got 30% the number of patches, doing the math over the last 12 months, a Server Core installation running Hyper-V, you would have had to reboot it at 8 times. So it's an improvement, but not a huge improvement. Over the same 12-month window, if you'd been running NanoServer, which obviously you couldn't have because we haven't shipped it yet, but in doing the math, if you'd been running NanoServer, you would have had to reboot your Hyper-V server twice. So that's a significant saving. And this is going to be a big area of investment for us. So please start looking at NanoServer. It's available today. The next area is containers. Now, I am not going to talk a lot about this. One, because I could literally spend an entire day talking about containers. And two, because I have a session tomorrow where I'm going to struggle to talk about containers in 75 minutes. So I would really encourage people to come to that session. The key thing to be aware of, there are 2 things I want to call out to this audience about containers. The first one is, this is a really brand new technology. We're super excited about it. We're going to be talking about it a lot. At the same time, I get a lot of people going like, hey, are we ripping out virtual machines or replacing them with containers? To which my answer is, you should probably wait until we at least ship the V1 before we have that conversation. So it's a very new technology. It's a great thing to be learning about. But our expectation is that for most people in the immediate future, you're going to continue to use virtual machines. The second thing to be aware of, though, is I get a lot of people asking me, hey, what are containers? Why are you guys doing this? How should I be thinking about this? Once again, session tomorrow. But the really high-level pitch that I like to give people is when we started building virtual machines, back in the late 90s, early 2000s, we had no idea about something called cloud computing. I was on the engineering team when we started working on Virtual Server, and if you'd come to me and told me about this idea of cloud computing, I would have looked at you like you were insane. Our primary focus when we were building virtual machines was just allowing people to do what they were doing with physical computers more efficiently. And there are a bunch of trade-offs that we made to enable that. For those of us who've been in the industry for ages, this will make sense to you. For people who are new, sorry, you'll just have to let this line go by. But I can actually remember we did work to enable people to restore images using Norton Ghost. That's the sort of design mentality we had. With containers, what we are doing is we're going back to the drawing board and we're saying, what does it look like to build something that is not designed to look like a physical computer, but is designed to be the best possible thing for building cloud environments on? So as I said, session tomorrow, I'll talk more about that then. So that was, what can we do to enable these cloud environments? The next big focus has been security. And when I talk to customers about public cloud, when I talk to them about hosted cloud, the #1 topic that comes up is security. And there are 2 angles here that really come up. The first one is just the issue of, can I trust that my data is safe? The second one, which in many ways is more tangible and more real, is that for many of us, we work in industries where we have regulations and compliance that says, we need to be able to provide guarantees around the security of our data. So this has been a big area of focus for us. Beyond this, let's be clear, the security landscape today is worse than it's ever been. And this is not just an old guy on stage talking about how the world used to be a happier place when I was a kid and we used to run into neighbors' houses and so on. No, this is statistically proven. This is acknowledged by the industry. The rate of attacks are increasing daily. The complexity and sophistication of attacks are increasing daily. The internet is becoming a more and more dangerous place to do business. And so we've been investing in what can we do to make it so that you can securely run your workloads in a public cloud. So I am going to switch across to my first set of demos. I will apologize, I'm going to be a bit of a tease. I have more demos here than I'm going to do. If I did all my demos, this session takes about 100 minutes, and they only scheduled me for 75. So the first thing I'm actually going to do is I'm going to bring up a Linux virtual machine. And while this is coming up, I want to do another show of hands moment. How many people here know what secure boot is? There's always too few hands, because the follow-on question to this is, okay, how many people here know what a rootkit is? Okay, most everyone knows what a rootkit is. And if you know what a rootkit is, you know what the correct mitigation for if you get a rootkit on your system is. It's to pretty much throw the system out. Maybe you can do a low-level format and hope that they didn't get into the firmware. But a rootkit is basically the worst form of malware you can get. Once you've got a rootkit on a system, you can't trust anything about that system anymore. Best case scenario, format and replace. Worst case scenario, the hardware is no longer trustworthy. So Secure Boot is actually a technology that we built in Windows 8 that is definitive protection against rootkits. And what it basically is that if you get a new laptop, if you get a new tablet, if you get some of the latest PC systems with UEFI capabilities, those systems have a Microsoft certificate in the firmware, and as Windows is booting, they will check for us that no one has tampered with any of the critical kernel components. And if someone has tampered with them, we're able to stop the system from booting. We're able to say, hey, someone has compromised us, we're not running. And that puts you in a situation where, yes, effectively you do still have to format and reinstall, but we can guarantee that a rootkit was never able to run code on that box. So when we did Generation 2 virtual machines, they also support Secure Boot. So Generation 2 virtual machine has native protection against rootkits. One of the great things for me is when we came out with Generation 2 virtual machines in Windows Server 2012 R2, on the day we launched it, we did not have support for Linux. And I had a bunch of people looking at me and going, you're being evil Microsoft and building something that only works for Windows. And I was sitting there going, no, we're working with the Linux community. It just hasn't come together. Since then, we've had a number of Linux distributions come out with support for Generation 2 virtual machines. For instance, this is Ubuntu running inside a Generation 2 virtual machine. But more than that, we've also been actively engaged with the Linux community to get Secure Boot support for Linux as well. So if I come into the settings for this virtual machine, you can see I've got Secure Boot enabled. I'm using the Microsoft Certificate Authority. And what this means is all the kernel mode components in this system are ones that I've got from Canonical, the authors of Ubuntu. It's been signed by them, and I know that I can trust this code. Now, if I wanted to run other code, I could. I'd have to turn off Secure Boot. If I come in here, I put together a little shell script and what this does is this just dumps some information from the UEFI firmware inside the virtual machine to confirm that Secure Boot is enabled. So here I have rootkit protection, not just for Windows virtual machines, but also for my Linux virtual machines. So that's the first security thing to demo, but the bigger security thing to demo is a set of functionality that we have that we call Shielded Virtual Machine. And I'm just going to demo one part of this, which is the virtual TPM. So this is a Generation 2 virtual machine with Windows 10 installed. And if I come in here, first thing you can see is I have BitLocker enabled on the hard drive. If I come into Device Manager, the reason why I can do that is that this virtual machine has TPM inside of it. Now, for industries where there's requirements that your data must always be encrypted, it must always be protected, this is exactly the capabilities that you need. So let me switch back to my presentation and talk a bit about Shielded Virtual Machine that builds on top of this. So Shielded Virtual Machine is a large scenario that we've been working on where the virtual TPM is just one of the three pillars. Because virtual TPM, as I mentioned, gives you, encryption of your data. But Shielded Virtual Machine is actually more than that. So the second part of shielded virtual machine is a technology set that we have where we are able to allow you to have a virtual machine on a Hyper-V server where even the Hyper-V administrator cannot access or interfere with that virtual machine. We've gone through and we've done a lot of work in the Windows kernel and in the hypervisor and in the entire Hyper-V stack so that you can now have a situation where a Hyper-V administrator can create a virtual machine, can give the user network access to it, and the Hyper-V administrator is then unable to access that virtual machine in any way, shape, or form. Now, this is really important if you're thinking about a hosted or a public cloud environment. And I know we already have hosters who are looking at this, and they want to provide it as an offering where they can tell their customers, hey, we can host your workload, and we can guarantee that none of the people running the data center can interfere with it. A secondary scenario for this, which is kind of interesting, is we know we have a lot of customers running trusted workloads in physically insecure locations. The poster child for this is people running read-only domain controllers in virtual machines in branch office environments. Those domain controllers have the password database on there. They're susceptible to an offline attack if someone gets access to it. But at the same time, you want to enable the local branch office to be able to do things like reboot the server and do basic maintenance tasks. So providing infrastructure where you can say, okay, you can have access to the physical box, but not to this virtual machine, is crucial for that. The third pillar here, so we have the virtual TPM, we have the protection from the host administrator, and the third pillar is the host guardian service. And the host guardian service is a separate service that you can set up and run on Windows Server 2016, where what it does is it does two things. One, it securely stores all the keys to allow your shielded virtual machines to boot. And two, whenever someone in the environment tries to boot a shielded virtual machine, the host guardian service is responsible for verifying the health and the trust of the physical server before releasing those keys. So these three technologies together give us shielded virtual machines. Now, I'll be very transparent on this. Setting up shielded virtual machines end-to-end is not an easy thing to do today. This is a set aside a week, read the 70-page white paper, and go through the process. But the thing that makes me most excited about getting this technology out there and being able to talk to people about it is for years now, I've been talking to customers about the problem of trust and data security in public cloud environments. And the attitude from people has been, Ben, this isn't a technology problem. This is a politics. This is a government. This is a process problem. You guys can't solve this. And we've been working on this, and we want to say, no, we can solve this. We believe that we can get to a world where you can run any workload you want in public cloud because we can provide a platform that provides all the protection and guarantees that you need. So that's been the biggest investment in security. As I mentioned, we also have the secure boot work. Beyond security, we then have isolation. Now, a lot of people look at me funny when I get to this and say, wait, security, isolation, aren't those kind of the same thing? So security is about making sure that someone with malicious intent cannot compromise your environment. Isolation is about making sure that someone, either with malicious intent or just thoughtlessness, cannot negatively impact the performance of your environment. So there are a couple of technologies we've been investing in here. The first one is our StorageQuas technology. So we started working on StorageQuas in 2012 R2. In 2016, we've made a bunch more investments here. I'm not going to talk much about the details here. I'll be demoing this in a little. I do want to have a bit of a chat about StorageQuas in general. First, a show of hands. How many people here can, off the top of their head, give me a ballpark figure about how many IOPS their private cloud can drive on storage? It's a very small number of hands, and that's kind of what I expect. So there's an interesting phenomenon. One, as an industry, we don't think about our storage throughput enough. And we're not used to talking about our storage throughput. But I spent a bunch of time going out and meeting with customers and looking at their deployments and understanding their deployments, and consistently across the board, the number one bottleneck, the number one cause of scale inefficiency, the number one thing that's stopping people from getting more out of their hardware is bottlenecks in storage IOPS. It just is. And another kind of ancillary, I said my number one call to action is go play with NanoServer. My number two call to action is go and profile your storage. Understand what capabilities you have, what throughput you have, where your storage is at. You will be surprised. And it is a really important thing to understand. So in storage QoS, what we are doing is we're going, okay, we understand that storage throughput in most deployments is a rare commodity. Chances are you're running out of it. So storage QoS gives you the ability to control and throttle and decide who gets what storage throughput at what time. Now, one of the big investments that we've made here is we've added the ability to do grouped storage QoS and storage QoS on the file server. And as I said, I'll be demonstrating that in a moment. But one thing I do want to call out on this page before I move on, this is just an interesting story. How many people here have VDI deployments? So this is desktop infrastructure running. Fantastic. So there's a story here that a lot of people have suffered from with VDI. And storage QoS can actually play a really interesting role. So if you look at, and first, what's the number one killer of VDI deployments? Everyone likes to say that the number one killer of VDI deployments is cost. That's a lie. The number one killer of VDI deployments is unhappy users. That's every time. Every time I see a VDI deployment abandoned, it's not because it costs too much, it's because the users were whining. And so when you're doing a VDI deployment, you go through and you size it out. And what I've seen happen is people go, you take a crufty old desktop computer with a single spinning hard drive, it pulls about 150 IOPS. So someone will go, hey, we're consolidating 400 desktops. They each have about 150 IOPS. So I'm going to get a nice shiny SAN array on the back end. It can do 30,000 IOPS. And as long as everyone doesn't go hot at the same time, everything's actually going to be better. And if everything goes hot at the same time, fine, we'll muddle through that. It won't be the end of the world. And they deploy that infrastructure. And for the first week or two, it's great. But people are fascinating creatures. And what happens is it doesn't take long at all before the end users realize that, like, hey, if I do stuff at 6 p.m., it's a lot faster than if I do it at 9:30 a.m. And they almost immediately forget that the performance they're getting at 9:30 a.m. is exactly what they had on their old desktop computer. Because, all of a sudden they've tasted the glory. They know what it's like to do this work when no one else is on and they have the whole SAN array to themselves. And then it's literally a matter of weeks before they start complaining about performance. And the funny thing is, they're complaining that, the performance is not much better than it used to be. So what we've actually seen a number of people do, and it's been very effective, is to go in and say, okay, for my VDI deployments, we're going to set storage QoS policies and say no individual desktop gets more than 200 IOPS. I don't care if the SAN is sitting idle. I want the performance to be consistent so that whether a user is using it at 9 in the morning, 10 in the morning, 1 in the afternoon, 9 o'clock at night, the performance is consistent. Surprisingly enough, it does result in happier users. Just an interesting anecdote there. The next thing that we've worked on, this is actually a kind of fun one. This is a bit esoteric. This is a feature that we built for Azure. It's a feature we call host resource protection. Now, this may surprise you. Hopefully it doesn't. But there are actually people out there who buy virtual machines from Azure for the sole purpose of trying to hack us. It happens. Now, the great thing is they've never succeeded. I can say that with confidence. We're a publicly traded company. If someone hacked Azure, we would have to do a disclosure on it. They have never succeeded. Yay, good team. But when they're in there trying, man, can they cause a lot of annoying disruption to the system. Because they'll buy a virtual machine, and they'll be trying to talk to I/O ranges that we don't map in. We have to fault them in, we have to handle them, we have to do the error handling, and so on. And it can actually cause performance issues for the virtual machines around it if someone's attempting to do a malicious hack. So in Windows Server 2016, and we've enabled this for Azure, we've also enabled it in the version of Windows that you get. We now have heuristics that detect this sort of activity. And what we will do, because we can't always be 100% certain that it is malicious, is we will just throttle back the CPU time of that virtual machine. We'll just slow it down so it has less impact on the systems around it. And once it starts behaving properly, we'll let it go back to normal. Now, if you ever have this happen, you'll actually see under Hyper-V Manager or host resource protection enabled. You should never see this happen. That said, we also have a registry key that allows you to disable this for a very amusing reason. As I've been saying, we built this for Azure. It was a big request from them for us to build this infrastructure in. Now, the current CTO of Azure is a fellow called Mark Russinovich, who happens to like to go on the road talking about malware hunting. And when we checked this functionality into Windows, we broke all his demos. It's fantastic. We got a frantic phone call from him like 2 days before he was going on stage, because he has these virtual machines that are just jam-packed full of rootkits and malware and all sorts of nasty stuff. And he tried to fire them up on Hyper-V, and we're like, no, and we gave it like 20% CPU. And all of a sudden, his demos were taking hours to complete. So hopefully, not something you'll ever have to deal with, but some interesting technology nonetheless. So the next area, and I'm going to spend a bunch of time talking about this, is availability. And availability is really anything we can do to keep your virtual machines and your workloads running. I like to say, two things I like to say here. The first one is when it comes to server administrators and uptime, it's like kids and candy. They can never have too much. I also like to say there hasn't been a single release of Hyper-V yet where we haven't done some functionality to help keep virtual machines up and running no matter what. So going into, and actually this is a conversation and some work that we started leaving Server 2012 and entering 2012 R2. I actually spent a bunch of time going around and having some really unpleasant conversations with customers. Normally when I go and visit customers, they want to talk about all the cool stuff that they're doing. They want to talk about the feature requests that they have. They want to have a happy, fun conversation. But coming out of 2012, we spent a bunch of time going around where we would go out, we would meet with a customer, and after a bit of conversation, we would say, okay, when was the last time you had a complete cloud outage? And boy, did you see some unhappy faces when you asked that question. That's always a sore topic. And the answer would come back 9 months ago, 12 months ago, 15 months ago. And we'd say, okay, step us through it. What happened? Why did it happen? Like, what worked? What didn't work? And we spent a huge amount of time out talking to people and gathering data about what causes cloud outage and what can we do to make it better. So the number one cause was storage outage. And this was, something happened. I had a SAN firmware bug. I had a cabling issue. We had a power glitch. We had something happened, and the storage went away. Now, the interesting thing is, the biggest pain point here was not actually the storage going away. Everyone storage is kind of foundational, and everyone kind of expects that, if the storage goes away, then you're in a bad spot. The biggest pain point was actually, there would be a glitch or a bug, and the storage would go away, and it would either automatically come back after half an hour, or there'd be panic stations, and people would get it back up and running. But then, because the storage had been away for 30 minutes, an hour, 2 hours, all the virtual machines would have crashed. Because all the virtual machines would have tried to write to storage, they would have failed, they would have crashed. And what the real pain point here became was not the storage outage, but was literally the days of work spent going through and checking all the virtual machines and making sure that all the apps were running and making sure that no data had been lost and going through and doing that. So to deal with that, we've built a feature called VM Storage Resiliency, which I'll be demonstrating in a little bit, where we actually detect these storage outages and we automatically pause the virtual machines, ensuring that there's no data corruption, no data loss. When the storage comes back, we resume the virtual machines like nothing happened. Now, there is still outage, but the guest OS doesn't crash. There's no potential for data loss, and the recovery is much quicker. So that was the number one thing we heard. The number two thing we heard, and I love this, because this is just like, in working in the field of IT and server administration, there are things that are true that we never talk about, but we just kind of accept them. And so I love this, because this is one of those. Let's do a show of hands, because it's going to be everyone's hand. We'll see. How many people here have had this experience? It's an afternoon at work. It's a sunny day. Life is good. Everything's working well. And then, for no apparent reason, the network goes away. Just gone. Yeah, we've all been there. Whoa, what's going on? And the best thing that I love about this is the network goes away, and you're sitting there and you have that moment panic where you're like, the network's gone, and the errors are starting to pile up, and before you can even start doing diagnosis, it's back. And you're like, that's weird. And you go and you do a bunch of analysis and you look and you find out and you don't know. And it just happens every now and then. So that one everyone has had. The other one, not everyone but many, and I always tell the story, it's always a colleague, it's never me who did it. But how many people wouldn't have done this themselves but have had a colleague who was updating a routing table on a switch or a VLAN on a switch and accidentally typed in the wrong thing? Yeah, not you, a colleague. Never you. But another thing, and it's the classic, it happens, your colleague, not you, hits enter, and the network's down in mad fury to undo it, and a couple of minutes later it comes back. So all these events are really problematic today for a Hyper-V private cloud, because Windows clustering, as soon as it sees a network outage, panics and goes we got to move workloads around, we got to kill the virtual machine, we got to start it up over there, and so on. And if it's just a short network outage, that's not actually what you want. So what we're doing in Server 2016 is we're putting some intelligence in Windows failover clustering where we are special casing specifically running virtual machines. This is important to understand. For offline virtual machines and for all other cluster resources, we're maintaining the old behavior. But for running virtual machines, we're basically going, look, the act of tearing down a virtual machine and starting it up on another computer is a pretty heavyweight act. It's not something you want to do lightheartedly. And so we're building in a bunch of controls where you can now control how long we wait for a running virtual machine before we say, okay, this node isn't coming back, the network isn't coming back, let's move it over. And the default we're going with is we're waiting for 4 minutes. That is configurable. But the idea here being that if you have these short outages, that we will leave virtual machines alone until we believe that something's really gone wrong. The final area of focus, and I love this one because this is, God bless engineers that we can come up with such terrible names. We've focused on solving the problem of flapping nodes. It's great. How many people here are willing to say that they've had problem with flapping nodes? So this is, as I said, we spent a bunch of time talking to customers, doing failure analysis, looking into it. And while the number one and number two were the storage and network outage, we found this really interesting and problematic case. And the interesting and problematic case was where you have a physical server that is repeatedly joining and leaving a cluster. It may have a piece of hardware that's on its lost legs. It may have a damaged network cable. It may have a buggy driver. It may have the wrong firmware on it compared to every other node in the cluster. But something's going on where it'll join the cluster, it'll run workload for 20 minutes, and then it'll panic, and it'll drop out of the cluster. And then 5 minutes later, everything's forgotten, everyone's happy, and it rejoins. And you have this pattern happening, and it can cause huge amounts of damage to a cloud environment over time. So what we've built in is we've built in some intelligence where we can now detect these patterns and act intelligently in response. And there are two parts to this. The first part is we now keep track of every time a node leaves and rejoins a cluster that isn't administrative initiated. So every time a node just leaves a cluster without a user saying, do this, we keep a tally. The next thing we do is we have a threshold. By default, this is set to 3 times in an hour. You can configure this. A lot of these things we're letting people tweak and tune. But we have a threshold where, by default, if a node has left and rejoined a cluster 3 times in an hour, when it comes back the 3rd time, we say, we don't trust you anymore. Like, something is wrong with you. And it comes back and it says, I'm healthy, I'm good. And we say, no. And the first thing we do is we live migrate any virtual machines off of that server. We get all workloads off there, and then we put it into a quarantine state. In a quarantine state, it's still a member of the cluster. It's still like event logs and all other actions and so on. It's still showing up, but we will not place workloads on that node. Now, you can configure servers to automatically come out of quarantine. By default, it is a manual action. So those are the first big 3 things that we've done around keeping your cloud up and running. We've also been spending a lot of time investing in the Hyper-V backup architecture. I'm not going to go deep in this. This is honestly about a 3-hour presentation in and of itself. But we've been doing a lot of work to make Hyper-V backup scale and work really well in large cloud environments. We've also been working on raising the bar on shared VHDX. So how many people here have guest clusters in their environment? So they have clusters running inside virtual machines. Okay. So how many of you are using shared VHDX? It's sad. Come on. Need to get more people on that. So shared VHDX is a technology that we released in 2012 R2. And in 2012 R2, the basic value of it was, hey, you don't have to do LAN management anymore. You can do a guest cluster just using virtual hard drives. But in 2012 R2, with shared VHDX, all of the trade-offs that you have to deal with guest clusters, you still had to deal with shared VHDX. Now, it is our goal that eventually a shared VHDX guest cluster will have all the functionality of a standalone virtual machine. In 2016, and in the current technical preview, there are a couple of key things that we're enabling. We now allow you to online resize shared virtual hard drive volumes. So even if it's a CSV volume, you can online resize it while the cluster is running, 0 downtime. We allow you to use Replica to protect guest clusters if they're using shared VHDX. And we allow you to do host-based agentless backup of guest clusters if they're using shared VHDX. So this is a whole bunch of stuff that used to be really painful to do with guest clusters, now just works out of the box. So I'm going to switch across. I'm going to do some demos. I'm not going to do all my demos, I apologize, because I have a timer here, and I'm getting nervous. Too many features. So first thing I want to show is let's do the Storage Quest demo. And I got the password right. Always stressful to type in passwords when you've got hundreds of people watching you. So what I'm going to do is, these are two virtual machines that are using the same piece of storage on the back end, and I'm starting up an I/O-heavy workload inside both of them. And what you're going to see fairly quickly is they're going to even out to just around 10,000 IOPS apiece. So in 2012 R2, we provided you the controls where you could go in and you could throttle one of these workloads. So for instance, I'm going to apply a QoS policy to storage workload 1. And this policy says, don't use more than 2,000 IOPS. And you'll see that storage workload 2 is now using a whole bunch of IOPS. Storage workload 1 is throttled. And this is great. It allows people to have greater control over who gets what storage throughput when. But the challenge is that often the guy or the girl running the Hyper-V infrastructure doesn't have a huge level of insight into what's actually happening inside the virtual machines. They're providing this as a service to other people inside the company or to external people. And it becomes really hard. I mean, think about how many people in this room didn't know how many IOPS their infrastructure had today. Try having a conversation with a person who wants the application, who wants a SQL server, wants a web server, about like, oh, how many IOPS do you need for that? That's not a conversation they know how to have. So a big thing that we're enabling in 2016 is the ability to do group IOPS. So I actually have a policy that says every virtual machine assigned to this no more than 2,000 IOPS. And I assigned storage workload 1 to it. I'm going to apply storage workload 2 to it. And what you're going to see is shortly, these will both balance out at 1,000 IOPS. Because now what I've said is any virtual machines covered by this policy, no more than 2,000 IOPS. And if I then come in here and stop this workload, let's say we stop it on storage workload 1, in about 30 seconds, the storage workloads 2 is going to be able to pick up those IOPS and consume them. Now, the great thing that this enables is it enables you to go at a person level, at a departmental level, rather than having a detailed conversation about like how many IOPS for this virtual machine, how many IOPS for that virtual machine, and so on. You can say, you know what? Finance, you're getting 10,000 IOPS for all your virtual machines. Engineering, you're getting 10,000 IOPS for all your virtual machines. And then, the first, when people start coming and saying like, hey, I want more performance, the first level conversation is like, well, maybe you want to throttle some of your own workloads. Maybe you want to be in control of that. And then you can get into the conversation about how you enable that. So just an extra level of flexibility here. I always have to remember to stop this at the end of this demo. Otherwise, it chews up I/O and slows down all my other demos. So that was distributed storage QoS. Now I want to show you storage resiliency. This is both a fantastic demo and the worst demo in the world. Every now and then I have to do these. I hate doing demos where I actually have to demonstrate a system failing. So what I have here is, this is another virtual machine. Its virtual hard drive is stored on an SMB share that's on a scale-out file server. I've got I/O running. And this script basically disables the network on the scale-out file server. So the first thing you're going to see is the IOs have dropped, but the virtual machine is still responsive. Now, the reason for this is in 2012, we implemented a technology called resilient file handles. And it's specifically for SMB. And resilient file handles gives you about 60 seconds of grace on an SMB share if you have a network outage. If I was using a direct attached CSV volume and I'd caused a storage fault, we would have gone into storage resiliency straight away. With SMB, there's a little bit of a lag for that. But I like to do this demo because I believe this is more realistic for what people will see in the real world. So what's going to happen is once we exceed the resilient file handle count, the first write operation where we actually get a response back that says, I have failed to do this. We will pause the virtual machine and start pulling the hardware. So here you can actually see, this is a bit of an eye test, so let me zoom in on it. So we've actually paused the virtual machine now, and And for some reason, my Zoom app isn't working. Let's try that again. Here we go. And we've gone into paused, and we've got an error message saying there's been critical I/O errors. So at this stage, this virtual machine is not responding to the network, but it's paused. I can't do anything with it. If I go into Hyper-V Manager, it shows paused. Now I'm going to reconnect the network cable. And what's going to happen is very soon, this is going to pop back to life. Because once it goes into paused critical, there we go. And it remembered that I clicked on it. So there we go. So it's popped back to life. So the great thing here is, if you think about a scenario where you have a storage failure overnight and it gets recovered from, without this functionality, this would have been a 3 a.m. call about how everything's crashed and everything's down. And it would have been a really crappy day the next day. With this functionality, you might not even know. The only thing that might indicate this might be some event logs the next day saying like, hey, systems went offline for 10 minutes, and then they came back. So we're really excited to have this functionality in there. So what else do I want to show? I will actually, to keep on time, I'm not going to demonstrate the cluster resiliency. I will demonstrate some other hot add and remove features. So I'm going to be talking about this in the next slide, but we've also done a bunch of work to support hot add and remove of various devices that we haven't supported in the past. The two biggest ones are networking and memory. So we now allow, on any Generation 2 virtual machine, you can hot add and remove network adapters. Whenever I do this, I have to be silly and add a whole bunch. There's a reason why I do this. It's an interesting thing to consider, is that on a physical PC, you can't add 6 network adapters at the same time. It's always something that you do one at a time. And when we were actually working on this technology, we found some bugs in Windows networking where it would freak out if you added too many at the same time. So we actually worked very closely with the networking team to get those all addressed. So I always like to go crazy on this and show adding a whole bunch of network adapters. And this is just super convenient because, come on, let's be honest. How many times, who here has created a virtual machine, started it up, and 30 seconds later go, oh crap, I meant to put 2 network adapters in? Yeah, we all do it. So very convenient. So I can now add all those, great, and I can equally, we need to do multi-select. I always want to do multi-select for remove. So I can also remove a whole bunch at the same time. And conveniently, you can see all the network adapters came up, got IP addresses, so everything worked. It's fantastic. So let's remove all those, yay. The other thing that we've added support for is this is actually a virtual machine that isn't configured with dynamic memory. It's configured with static memory, but we now support hot resize for virtual machines with static memory. Now there is a bug in this build. I'll point it out because it bugs me every time. So if I come here, I can say, let's do 2048. Yay, I just doubled my memory. Equally, I can decrease. Now when I decrease, what you're actually going to see, the bug is this number doesn't change when we go down. This number down here changes, this number over here changes. The graph changes. Every number changes except for the biggest one on the screen. Really annoying. So look, there, I removed, this number changed, this number changed, the graph changed, that number didn't. Bugs me every time. Joys of using pre-release software. So there we go. So that's hot add and remove. So with that, let's jump back to, let me hit the button on this, and let's jump back to presentation. So I've been talking about the hot add and remove functionality. I showed you memory and network. We've also done some work around making hot add and remove of storage play better with Hyper-V Replica. So we've had complaints about like, hey, if I hot add a disk to a virtual machine that's replicating using Hyper-V Replica, things get all sorts of squirrely. So we now, 1, handle that scenario better, and 2, we allow you, while a virtual machine is running, to change the virtual hard drives that are being replicated. So it's very easy to add a virtual hard drive and then add it to the replica set. Similarly, you can remove virtual hard drives from a replica set and then remove them from the virtual machine. The next big area of investment, this is something that we've been working on for a while, and I'm super happy to have this, is support for rolling cluster upgrade. So you can upgrade a cluster, a Hyper-V cluster, from 2012 R2 to 2016 with 0 downtime and 0 new hardware required. Yay! Yeah, it's okay to applaud. Yay! And this, by the way, this is one of the reasons why I said, you know, if you've got any 2008 R2 or any 2012, get it to 2012 R2. We're spending a lot of time making sure that 2012 R2 to 2016 is great. We're not spending a lot of time working on 2008 R2 to 2016. You know, so your best experience for that is going to be 2008 R2 to 2012 R2, 2012 R2 to 2016. Now, the process for doing this is fairly straightforward. Basically, what the process looks like is you take your 2012 R2 cluster, you, one at a time, you evacuate a node, you eject it from the cluster, you upgrade the node, you add it back into the cluster. At the end of the process, you know, once everything's at 2016 level, you then go through and there's a final step to say, okay, upgrade the functional level of this cluster to 2016, and then that unlocks all the 2016 features. Now, there are two things I want to highlight here. The first one is, while you're in this mix mode, you know, you can, all the cluster functionality is supported. You can live migrate, you can quick migrate, you can move virtual machines in any direction. The second one, and this is actually one of the things that we really focused on, is the ability to roll back. So another common story, something that we've all had. You know, everyone here has at least experienced or talked to someone who has experienced the, like, hey, we've got a new piece of software, we're really excited about it, we upgrade, we deploy, life's good, then a week later, things start falling over. And we start digging in, and what do we find out? Oh, we've got this other piece of software, whether it's a driver, whether it's some infrastructure software that we use, which doesn't support that yet. And you go out and you're like, oh, crap. You go talk to the vendor, and you say, what's going on? And the vendor says, oh, yeah, we're working on that, and we will have that to you in 3 months' time. And you're sitting here going, I have servers crashing today. I can't wait for 3 months. So one of the really cool things here is, with the way we've done the rolling cluster upgrade, you can upgrade every single node in a cluster to Server 2016. If you don't upgrade the functional level of the cluster, you can actually then roll back every node to 2012 R2 with 0 downtime. So you can upgrade an entire cluster to 2016. You can spend a good couple of weeks making sure that, you know, your hardware, your workload, everything works well, and only once you have high confidence can you, say upgrade. But if you hit any problems in that process, it is always possible to get back and then work with the vendor in order to get things supported. So from the underlying Hyper-V side of things, the big work that we've done here to enable this is adding support for explicit versioning of virtual machines. The idea here is, in the past, whenever you bought a virtual machine to Hyper-V, we would instantly upgrade it to whatever version of Hyper-V you were running. With 2016 and with Windows 10, if you bring a virtual machine from a previous version of Hyper-V, we keep it at that version. And in keeping it at that version, no, you don't get access to the new features, but we maintain 100% compatibility with live migration, with checkpoints, with safe states, with everything. And because of that, it now becomes possible to enable all these new scenarios. Now, we do have a process where you can shut down a virtual machine and you can update the VM version. You can do that in the UI. You can do that in PowerShell. Once you do that, it's a point of no return. That is now an updated virtual machine. Now, I mentioned right at the beginning the Windows 10 Insider program. One of the things we actually just put out on the Windows 10 Insider program is the latest Windows 10 build. When you do a new VM using PowerShell, you can actually now specify a version. It's really handy if you're in an environment where, say, you have Windows 10 on the desktop, you have Windows Server 2012 R2 in your infrastructure, you can now go to Windows 10 and say, hey, can you create a new VM, but can you make it a version 5 VM? Because that's the version that 2012 R2 uses. And then we create that virtual machine in a way that's completely compatible so you can move it back and forth. So I did this demo a little early so I could get to my favorite section. My team teases me about this because we always do this. Every release that we work on, we have a set of features that we do because we just really want to do these features. And they don't actually align to any of the big vision-y stuff. And we always come up with terrible names for it. So the name that we came up with this time was Operational Improvements. It means nothing. Shh. This is just cool features that we did. So a bunch of cool features. So first one is a feature called Production Checkpoints. And I have to grill people here and I have to tell a story. So how many people here use VM checkpoints? How many of you use them on production servers? Yeah, be honest. Saw a couple of hands. You do know we don't support that, right? So the background story here is we've always wanted to support checkpoints for production workloads. And when we were designing the first version of Hyper-V, we looked at what was involved in doing this, and we realized that there was a whole set of technology that we needed to pull this off that just wasn't there yet. But we really wanted to do checkpoints. So we did all the work to do as good as we could do, and we put documentation everywhere that we could think of to say checkpoints, they're a dev test only thing. Don't do them in production. Don't do them in production. Don't do them in production. Well, 12 months after we released Hyper-V, the #1 support call generator was people shooting themselves in the foot using checkpoints in production. And I am the program manager who's always owned checkpoints, and let me tell you, if you're the program manager for the #1 support call generator, you get to meet the VPs. It's great. Seriously, I got to spend 2 years of my life where every 3 months I was meeting with the VPs, and they were saying, Ben, what are we doing to stop the fact that we're paying huge amounts of money helping people deal with the fact that they've hurt themselves using checkpoints in production? And so with every release, we've been slowly investing in making changes both small and big to make checkpoints safer. Interestingly enough, when we first released checkpoints, the #1 support call generator was actually that we hadn't put the word, we used to call them snapshots, we hadn't put the word snapshot in the file name, and so people would see it and not know what it was and delete it. It was terrible. I was like, worst support call in the world. Like, I found these large files on my disk, so I just deleted them without asking any questions, and now my virtual machine isn't working. So it was literally the #1 support call generator. Like, so thankfully that was a small one. We just changed it to put the word snapshot in the file name, and that at least stopped people from deleting them. But then we didn't used to support live merging of the disks. When you deleted a checkpoint, we added that. That got rid of a lot of support calls. At the same time, we've been talking to people about why are you using checkpoints in production? And what we found is a very consistent pattern. Checkpoints in production, 1, there's only ever one of them. And 2, they're used as a security blanket. The basic scenario is you're working on a server, and you're going to do something which you believe is safe, but you're not 100% certain. You're going to apply an update. You're going to make a configuration change. You're going to do something, and there's a little thing in the back of your head going like, yeah, do I really want to do this? And so what you do is before you do it, you take a checkpoint. And then you do the operation, and 99% of the time, you're fine. And you wait a couple of days and you delete the checkpoint and life is good. But if something goes wrong, you can always roll back to the checkpoint, right? Well, the problem is, for a production server, when we take that checkpoint, we capture the memory state. And if you roll back to that checkpoint, that Exchange server is going to resend the emails that it was in the middle of sending. That SQL server is going to replay the data that was being written to it when you took the checkpoint. It's not great for a production workload. So with production checkpoints, what we do is we give you the full user experience that you have today with checkpoints, only instead of capturing the memory state, we use VSS inside the virtual machine to take a production-grade backup of the environment. So it's fully supported, and we know that it's always a safe and reliable thing to do. Next feature is one that I love, PowerShell Direct. How many people here use PowerShell? Woo. How many people here have set up PowerShell remoting? Oh, that's more than I usually see. Now for the fun one. How many people enjoyed setting up PowerShell remoting? Wow, no one usually there's someone who's like, oh yeah, I love setting up WinRM. No one put their hand up. So what PowerShell Direct is PowerShell Direct gives you a PowerShell session inside the virtual machine via magic. No network configuration needed. In fact, no configuration needed at all. We worked with the PowerShell team, and we took their technology for PowerShell remoting, and we enable it directly over VMbus. And I'll show you what that looks like in just a moment. It's really powerful. On the engineering team, we've fallen head over heels in love with this. Then there's a bunch of work we've done with REFS. I'm going to demo this rather than talk about this. And we've also done a number of improvements to Hyper-V Manager, supporting things like alternate credentials and using IP addresses. So I'm going to jump over to, this is going to be the last demo I do. I'm watching the clock. We are running out of time. This is such a hard session to do in 75 minutes. So, a couple of demos. First one, I mentioned NanoServer at the beginning. Here I have a NanoServer virtual machine. So let me log into this. So a couple of things to highlight. This is actually a NanoServer. It's currently running a Node.js server. And if I bring up details on it, a couple of things to show. If I go to the memory tab, it currently has 256 meg of memory assigned to it. It's only using 140 meg. So 140 meg of memory for a web server. If I come and I look at the hard drive, I have to inspect the parent, but it's a 40 gig VHD, but it's only using 450 meg. So teeny tiny. Now, one of the interesting things is in making a streamlined server for cloud environment, what it doesn't have is a desktop or a console of any kind. It is for remote management only. So there's no way for me to interact with this here. And to make this really fun, what I'm going to do is let's go to the networking tab, and let's turn off the network adapter. Always a safe thing to do. So I now have my nice headless NanoServer with no console and no IP address. Seems like that would be a bit of a problem. But it's not. So let me bring up PowerShell now. I'm going to make my font nice and large so that people can actually read it. Just a moment. So what I'm going to do is I'm going to use PowerShell Direct. I'm going to say enter PS session, VM name, nano, Node.js. It's going to come up and ask me for the credentials for connecting to that virtual machine. I'm going to type them in. Oh, and I got no, I hit a bug. Let me try that again. Much better. So what's happening now is we're launching a PowerShell session inside the virtual machine, and I've connected. And I now have one full interactive access inside this virtual machine. You can see there is my Node.js installation. I can do get process. You can see the process is running inside of it. And I can do everything, and this is full PowerShell. I can use invoke command, I can do pipelining, I can do everything I want, even when the network's not there. Hugely powerful for build and automation, and also just a very handy debug tool. So that's PowerShell Direct. Let's throw that away. The next thing I want to do is I want to show REFS. So I'm going to kick this off. For a while now, we've been working on REFS, and we've been talking about REFS, and we haven't really had a compelling reason for people to use REFS. You know, if I'm in a polite mood, I say, for the last couple of releases, REFS has been more of an academic exercise. If I'm not in a polite mood, I say for the last couple of releases, we've been talking about REFS and saying, look at little Johnny, he's not much today, but when he grows up, he's going to be awesome. So 2016 is the first time that we have some really cool stuff that we can do on REFS. So what I'm going to do is I'm going to kick this off. And so here I have my enterprise-grade storage, by the way. This is what I'm doing this on. This is a spinning disk on a USB drive. And I've just said, create a 1 gig fixed VHD on an NTFS partition on that drive. And NTFS has no intelligence about block objects. So to do a 1 gig create took me 25 seconds, and we had to go and write out 1 gigabyte of zeros. Well, we had to by hand go, and so it takes time. Now, how many people here have got to experience the joy of spending an afternoon watching fixed VHD creation? They're good times. Good times. Nothing. I've had that myself. I actually have in my home deployment. I have a 5 terabyte fixed VHD. Nothing like just sitting there and watching that bar move slowly across the screen. So let's do the same on REFS. 1 second. That was a lot faster. So let's create a 50 gig disk on REFS. Also 1 second. This is the same underlying hardware. Now the thing to understand here is REFS is a very different file system to NTFS. The way REFS works is it basically has a collection of blocks, and then it has file descriptors. And the file descriptors are just arrays of pointers to the collection of blocks. So if you go to REFS, so one, just to highlight, you cannot go to NTFS and say, give me a 50 gig file full of zeros, because NTFS isn't smart enough for that. You can say, give me a 50 gig file, and then you have to write out the zeros. REFS you can go to and say, give me a 50 gig file full of zeros. And what it will do is it will create one block that's zeroed out, and then give you a file descriptor where all the entries point to that one block. So no matter what size it is, it's a very quick operation. The more exciting one for me, though, is disk merge. So I have my enterprise-grade storage here, 2 partitions. I have the same files on there, and I'm going to merge them first on NTFS. Now, before I get going, yes, we have a bug. This progress counter is broken. It's going to get to about 3%, and then it's going to be done. So don't be nervous when I'm talking and it's still at 2%. We're almost there at 2%. So when you do a merge on NTFS, and you do merges all the time, if you create checkpoints and delete them, we merge. If you're using replica, we merge. If you're using backup, we merge. On NTFS, we have to read all the data out of both of the files and write all the data into a new file. So as you can see, that took 31 seconds, but more importantly, the whole time that was happening, my storage was hot. Like, we were moving a lot of data around. If I do the same operation on REFS, it takes 2 seconds. And more importantly, no data was copied. Because with REFS, once again, keeping the mental model of its blocks and its file descriptors, we can go to REFS and give it 2 file descriptors and say, give us the union of these 2 things. And it can go and construct a new file descriptor without having to move any data. So very fast and very low impact on the underlying storage. And all this means that in 2016, we're going to be making strong recommendations that REFS is the primary file system people should be using for storage of VHDs. So I'm going to jump back to my presentation. We've got a minute, and I've got a bunch of slides. So we're going to try and scream through this. So I'm going to go really fast. We do have final work around improving the platform. We have a new virtual machine configuration file. We're moving from XML to a binary format called VMCX. And we're doing this for 2 reasons. One, we have been getting reports of people getting corrupted VM configuration files. That's a bad thing. And we've been working on trying to stop that. Using a binary format, we can have a resilient logging mechanism to ensure that we do not get corrupted configuration files. 2, this is kind of interesting. At scale, we do see performance issues with it. But we've made change here. The biggest thing you'll see is it's not .xml anymore, it's .vmcx. We've done a bunch of work in the hypervisor power management, where the primary goal here is to play well with the great power-saving technology in the Surface 3 and the Surface 4 and similar laptops. We enabled a new technology called Connected Standby to give these devices long battery life, but it wasn't compatible with a hypervisor. So we've fixed that now. We've also done a bunch of improvements on remote effects, increasing the version of OpenGL we support, adding support for Generation 2 virtual machines, and this is fun, I get to talk about this because we haven't actually announced this yet. It's now supported on Windows 10. I keep on bugging my marketing team and saying, when are we going to announce this? If you have the Windows 10 full upgrade, you can go in and enable remote effects on a Windows 10 computer running Hyper-V and get really cool 3D graphics. I've been playing lots of Torchlight 2 inside of virtual machines recently. Works great. The final thing to talk about before I wrap up is, as I mentioned, this is all talking about what you can play with today. We are not yet done with Windows Server 2016, and we do have some more features coming. We've already talked publicly about the fact that we're going to be supporting nested virtualization. Really cool. I love this for building demos, but we're also focusing on getting it enabled in Azure. We also have a new feature coming out, which we're calling Direct Device Assignment. So stay tuned for that. We're going to have some announcements coming about that over the next week or two. So with that, I am 1 minute over. Biggest call to action for everyone, please go play with NanoServer. That was my number one, play with NanoServer. Number two, understand your storage, start looking at storage infrastructure. And number three, if you get through both of those, start playing with all the features in Hyper-V and giving us feedback. You can follow me at Virtual PC Guy. Always happy to hear from people. So thank you all.